Hi, I'm Martin Smith, and I'm going over photon amplitude. And I was tracing back gravity, did the long run, found out that there were some questions about how a photon actually traveled and how fast it went, and if it had spin, that part of the photon was actually going faster than light. And I needed to backtrack to find out how fast gravity was going. Is it going exactly the speed of light? Is it going faster or slower? And 30 plus years ago, nobody really knew. So I came up with, started looking at the photon amplitude, just solved some equations, came up with one that really seems to work, and I've been able to find it multiple ways, or at least more than one way. And using the Bohr radius and the 21 centimeter wavelength that most people consider to be spin flip. So looking at that and applying it to different ways in which photons interact with matter, electrons, protons, all sorts of different types of matter, I came to the conclusion that photons have to be able to interact 3 different ways. And I'll be going over all 3 of those different ways on this video. Okay, back to the photon amplitude theory, starting with it, trying to get to gravity from there. One of the problems with the photon amplitude theory is that it goes against the spin up and spin down criterion for the electron. This exercise does not require spin up or spin down to be wrong, but it does require the process concluded to be wrong. The spin experiments used the entire atom to conclude that the electron had spin up or spin down, when it could have just as easily have been the proton that spoke for the entire atom, and then influenced the electron when it was pulled away from the atom to take on the proton's properties. The theory that I am using pretty much requires the spin of the electron to have a positive and 2 negatives, and it being spinning in this direction. Now I am using the low energy form of this electric muon or something like that, the lightweight. Normally this piece, the positive side, would be a little bit heavier, and it wouldn't exactly be a full spin. So I'm using the full electron, which is a little bit different than what you're seeing here. But the gist of it is it's that in my theory the spin of it has to go this way as it travels. The easiest way to think of it is it's spin up or spin down as it's going around the center. And that is the spin up and down criteria that we're using today. And it doesn't quite work for what I'm doing. So I'm not throwing this theory out yet just because it goes against the spin up and spin down. Another thing you have to remember is that we're getting to the size that if we look at something, we have already changed it. That is to say that these items here are so small that what we use to see it and to see what's going on has a bigger energy state than the electron itself. So we're pretty much tearing things apart just to even look at it. Okay, for photon amplitude to get me to gravity, it will need to work in 3 ways. The first way is a photon being transmitted or absorbed by a 3-point system, that negative, positive, negative, or the other way around, in the same direction of travel. That means a photon's coming this direction. In the case where I used H2O molecule with the tuned to a microwave, such as a microwave oven, the photon actually hits it and it moves it forward. So it's tuned a little bit slower, so that it's always speeding the atom up. It's always speeding the molecule up so that it gives it more speed and creates heat as it vibrates back and forth. The other one is when it deals with an electron, and what's happening there is if you have 2 points hitting 3 points, what's going to happen is it's going to put wobble into it, or it's going to throw it out in some weird direction. It's not going to be stable. It's not going to be moving stable. And when you have spin it helps to have stability in it. And the only way it's going to have stability is if it's orbiting in, or moving in this direction around an orbit. For an electron to go from one orbit to the other, rules of orbit with the planetary bodies, it requires it first to go into ellipse. So right here in this small little point, it gains enough energy to jump from here to here. And the rest of it, it's just following suit as it's going around in an ellipse. Now where it's gaining its next point of energy comes down to the third point of photons, where they're not always complete to size. So it's gaining energy here to stay in this orbit. The third one is, I guess I ought to bring it up a little bit, show the example here. This would be photons with a larger wavelength than radio waves, in which the photon hits a point mass with one of the two electric charges that a photon has. It gets absorbed and pushes it in that direction. So what's happening is it's hitting this one and not that one, and that creates a shadow. So this one's getting hit more often than this one, and the net value is that it's being forced this way. And the reason why this one isn't hitting that one, or spreading out and giving some reflection here, is because it has a magnetic field to it that will be moved around by the magnetic fields in space randomly. So it's just as likely to hit it this way, or go off and hit some other atom in some very strange places. And what's being happened if you multiply this, say, times 10 to the 24th collisions per second, it will have a net value of very small forces pushing these two masses together. And that is my belief of what gravity is. And that is what I'm trying to get to. Haven't really gotten there yet, but I'm working at it. Going back to finding the amplitude of a photon, I went with the Bohr radius versus the 21 centimeter wavelength that hydrogen atom produces, and I got 2.5125444671 times 10 to the minus 10th, and that would be the radius of the helix of a photon, and that being the amplitude or the radius. Multiply that by 2 and you get the diameter. And how I got it, I used energy in joules equals 1/2. That one being take a guitar, something like a guitar string, take the full wavelength of it, take the mass of the string within that wavelength, and you have a mass here. And again, the problem is that there's a constant in there if you're comparing it to a regular mass. In order to change that mass in kilograms, you have to multiply it by a constant. It's frequency squared, amplitude squared, and velocity. The velocity I changed to the speed of light. If Einstein can do it, I feel that I can too. And last time I put this equation in joules up against mass times speed of light squared. This time I'm going to use Planck's constant times frequency and solve it the same way and get the exact same answer. So bringing Planck's constant out, it changes to wavelength mass times the speed of light. I come back here, I've already changed that one, and I'm killing what my frequency squared, I'm killing the squared, I'm crossing out the speed of light, and I'm crossing out a mass, leaving me 1/2 constant frequency amplitude squared equals lambda. Going through here, eventually I come up with amplitude equals lambda times a constant. This here is a unknown constant times a constant as the speed of light, and the number 2 is also a constant. So I'm taking all those, putting them all together, and putting it down as one unknown constant. So that is what I'm looking for. And how I came up with that, I took the Bohr radius divided by the wavelength. So if I take the answer here and multiply it by the wavelength, I get the Bohr radius again. So my answer on that again was 2.5125444671 times 10 to the minus 10th, and that should be extremely accurate. In fact, I still round it off to 2.5 times 10 to the minus 10th just because it's easier. Now, instead of saying that this wavelength came from spin flip, I'm saying that it came from two differently charged particles with an acceleration, or in this case a deceleration, when you have a full hydrogen atom, nucleus and electron, being bombarded with a high-speed hydrogen nucleus, which is just a proton. And when it gets to this point, or getting close to this point, it creates a capacitance. When it hits to this point, it triggers and it forces this. Well, if this electron is in just the right place when this hits here, then it would force this electron through the nucleus to the other side, giving off your 21 centimeter wavelength, giving off that exact amount of energy. And that's where I'm getting this from. I'm saying that it is not spin flip. I am saying that it is from a collision. And this doesn't have to be right. This is, let me put this in exact terms, this is a swag. This is a scientific wild-ass guess. And that's where we are at this point. Okay, on this page I am looking to solve for my unknown constant. I did the math for it here. I came up with a constant equal 1.05, so on, and that's times 10 to the positive 11th. I accidentally put a negative there, slip of the hand, so I changed it to a positive when went on. And when I took this number, put it into C, and solved for it, I got my main number again. I left off the last digit. It's not a big issue. And that solves that page. After that, this video is really supposed to be about having 2-point charges being accelerated together, and when they get to a particular point, they produce a photon not in the direction of the acceleration, but in the direction of 90 degrees of the acceleration. So this is a different process of photon generation from 2-point charges. This is the process we see in radio antennas, such as dipoles or monopole antennas. I'm going to use a dipole antenna because that's what I was able to get numbers from. The AM and FM radio antennas, they have lots and lots of information out there, very precise numbers. The problem is they don't give enough information to complete what I need to get. Yes, they do measure things more precisely, but they've left out so much information that I cannot bring this back down to figuring out how photons are actually created. The first one that I needed to get was finding out the number of photons. Number of photons equals power in watts over energy in joules. I have energy in joules equals Planck's constant times frequency. So I go power in watts times Planck constant times over Planck's constant frequency. So I write all this down, and with the numbers that I get for 100 watts, Planck's constant, and the frequency that was given was 7.5 times 10 to the 6th, or a 40 millimeter dipole antenna. And this is the ham radio operators that gave me this information. They are the type of people that go out and spend $10 on a roll of wire and a roll of duct tape and just cut it down until it works. So my numbers are not all that accurate, but at least they gave me all the numbers I needed to finish this out. Let's see, here's my numbers that I was able to get. 100 watt dipole, they're using a 40 millimeter wavelength, which is a 20 millimeter antenna. They used 22 gauge. They measured it out at 73 ohms. The 22 gauge is 25 thousandths and 3/10 of an inch. That comes out to 0.996 millimeter diameter for copper. The copper atom itself is 1.28 angstroms, and I'm going to work with that in meters, so it's 1.28 times 10 to the minus 10th meters. So what I'm doing now is I'm looking to see what kind of interactions and actions are required to actually create this many photons. So we have created in this 2 times 10 to the 28th photons per second. Bringing it down here, number of photons, 2 times 10 to the 28th photons per second. Now that is one boatload of photons. That is a bunch. Okay, this is where the problem begins. When I get this here, I got to divide by 2 because I'm only going to work with one leg of this dipole antenna. It's just easier that way. So that drops it down to a small fraction. I'm working at 10 meters length of copper wire. The copper wire, the diameter of the copper itself is this, so that gives me 7.8125 times 10 to the 10th copper atoms per quarter wavelength, or one length of the dipole antenna. That's not even close to enough. So I'm looking at the 22 gauge, and when I look at the 22 gauge, it is 0.996 meters diameter, and I need to look at the circumference of it. So that's 996 diameter times pi, gives me 3.129 times 10 to the minus 3. I take that number and I divide it by the diameter of the copper atom again. So that tells me I've got 2.445 times 10 to the 7th copper atoms going around that copper wire. So that's how many I have going around. So we take this number, multiply it by the length, and this tells me how many outside atoms of copper I have on this one half of this dipole antenna. And it's 1.91 times 10 to the 18th. Now this is times 10 to the 18th if you look at that. And this number up here is 10 to the 21st. So I need at least 1,000 more interactions than I have copper atoms on the outside. So this is where I start doing some more calculations. And what I'm looking at is the amps. I need to know how many electrons are pushing into, I guess I should look at a picture here. I need to look at how many electrons are pushing into this antenna. So to find that, I have to come back from the beginning here. And I'm looking for amps equals watts over resistance, so we get 100 over 73 ohms, gives me 1.17 amps. Now electrons per second, that's electrons that pass through a single point per second, is amps times 6.242 times 10 to the 18th. So we have electrons, and I don't need seconds, I need electrons per frequency. In fact, I need electrons per half frequency, but we're going to get frequency for now. So I have amps times that divided by frequency, and I get 9 times 10 to the 11th. So every time this thing goes through a full cycle, I'm getting 9.7 times 10 to the 11th atoms. Every time this thing goes through a full cycle, I'm getting 9.735 times 10 to the 11th electrons passing into the base of the antenna. And what's happening here is this would be a cycle of a wavelength, and I need to find this area under here. I believe that that's the number. I haven't really looked it up, but it is a close enough approximation for me to go with it. So it's a 0.707 for half of, or I should say a quarter of that frequency. I need half the frequency. So it'd be 35.35% or 0.3535. So I multiply that by the number of electrons being pumped into the base of it, and I get 3.442 times 10 to the 11th electrons. And that added to the other electrons still doesn't make up the difference, but if I'm forcing those to pass each of the photons, this one here gives me nothing if I remember correctly. Okay, copper. This is supposed to be electrons being pumped in, was 3.442 times 10 to the minus pumped. The copper atoms around it would be 2.445 times 10 to the 7th. That tells you how many atoms are going around the diameter of that. So if we pump in one on each ring, we're pumping in, so this here would be the ring. So we divide this, and that would tell us how many electrons, or how many rings of electrons have, how many electron spaces each one of these electrons is being advanced towards, from here towards the end of the antenna. And that advancement is what pushes electrons past the protons, and that the pushing is what generates the photons. So I'm getting 1.91 times 10 to the 18th atoms times 14, and that gives me a number that is greater than the number of photons being produced. So I'm saying yes, this is a capable scenario. So we are taking electrons going this direction, putting them up against protons here, squeezing them together and forcing out 1 point charge here, 1 point charge here at a diameter, and creating a helix, as in one photon. Very, very small energy, but it is a photon nonetheless. And this completes number 2 of my project, saying that it is possible for photons to be generated at a 90-degree angle of the motion of the electrons. If this amplitude theory proves out, it does go against the spin up and spin down, which is a major problem. It's hard to disprove something that everyone takes for granted. It does say that photons have to be generated in 3 different ways. Well, at least for gravity to pan out the way I want it to pan out. And it says what gravity is actually made of. They're not actually, well, I'd like to say they're not actually gravitons, but if you're creating a new wavelength, or a new list of wavelength, that is, the wavelength is larger than radio waves, it's larger than the frequency we use to transmit electricity. and it is so large that the forces holding the photon together are so weak that one part of the photon can strike an object, become part of that object, leave its mass and its energy with that object, and allow the other half of the photon to keep going. It's basically a vortex wave to meander through space for either large periods of time or not. The balance would most likely be far enough away from a galaxy where the galaxy no longer pulls that object or pulls that particle into it for spin. So once you get out that far, it's pretty much neutralized. Gravity itself neutralizes itself. The other balancing force that gravity would need would be black holes. It would need more black holes than what's in the center of our galaxy, and that's a problem also. So I'm not sure how that's going to come up. But it really does require for these vortex waves, these real small vortex waves, to be able to reconnect with other vortex waves to create smaller photons. It requires that requires a lot of things that who knows if it'll work or not. And I'm going to keep working on it just for the fun of it. I'll see y'all later.